Okay, so first thing is there's homework due tonight. It's homework number, I think it's homework number 6. Yep, homework 6 is due tonight. Homework 7 is due Tuesday, the 26th. T6. I forgot to make a quiz last week, but I have made a big note to self, it's on the wall, to make a quiz today. So I'm going to post a quiz. It'll be less than 5 questions, and you'll have a week to do it. I think this is quiz number 4. And I have a little bit of notes to share with you to finish your homework 6. If you need time for homework 6, just write a message to me. I could always add an extension to any assignment. And then we want to start the notes for homework 7. Both topics are about factoring. So we need to do the greatest common factor, factor by grouping, and then we're going to factor trinomials. We're going to factor a difference of squares. And probably on Thursday, we'll talk about how to solve a problem using factoring. So we left off with the greatest common factor. So you look at all of the terms in your expression or in your polynomial, and you have to have factors common to every single term. And I guess as far as greatest goes, the most of that factor that is common to each term. Let's do an example. Okay, let's go with factor out the greatest common factor, the GCF. 8x minus 16y. I'm going to do scratch work first. So let's find the greatest common factor. Because I kind of need to work with it. We're going to factor each number. So 8 is 2 times 4. 4 is 2 times 2. 16 is 2 times 8. 8 is 2 times 4. Is 2 times 2. Okay. So there's a 2 common to both terms. And there's another 2 common to both terms. And another 2 common to both terms. So like a common factor is 2. And then in this case, with the greatest common factor, we're taking the least of that factor, which is these 3 over here versus the 4 over there. With the variable, like the variable x, it is not common to both terms. There's only an x in the first term. So we're not even going to use x. And as far as y goes, y is not common to both terms. It's only in the second term. So our greatest common factor is 2 times 2 times 2. So we want to factor out 8. So I'm going to just rewrite what we start with. Like the expression is 8x minus 16y. We're going to be factoring out 8. So if we take that out of this first term, it leaves x. We take 8 from 16y. We'll also copy down that minus sign. This will leave a 2 right here and the y. And that's as much as we can do. And that's your answer. So we're trying to take an expression and write it as a product of polynomials with the smallest powers as we can get. If we could factor this further, we would, but this is as far as this part will factor. Let's just do more examples. So part of what this is saying is whatever expression we have, we're going to rewrite it as a product of polynomials. Hopefully, each piece of that product will have as, how do I say this? Small of an exponent as possible, like is fully factored. It's 14x to the 4th, y to the 4th. And then add 35x cubed y squared. Let's do scratch work to get the greatest common factor. And by the way, whenever a problem says factor, I kind of start with looking for greatest common factor and then kind of looking to see if you have 3 terms, which is a special setup we'll talk about today, or look for a difference of squares. Or try one of those and then see if you can do something else after that step. Okay, I'm rambling. All right, I'm going to factor each of the numbers. 14 is 7 times 2. 35 would be 7 times Greatest common factor. So you have two terms. One common factor is 7. There's a 7 in each. There's a 2 as a factor, but it's not common to both terms. There's a 5 as a factor over here, but it's not common to both of the terms. There is an x in both terms, and for the variable, take the smallest power. So use x cubed. And then for y, we're taking the smallest power, which is y squared. And it's all multiplied together. 7 times x cubed times y squared is the greatest common factor. Rewrite the expression. And it will factor into a product. One part of the product is the greatest common factor, 7x cubed y squared. Multiply with. From the first term, we take out 7, which leaves behind a 2. We take out an x cubed from x to the 4th, which leaves an x. And from y to the 4th, we're taking away y squared, so 4 minus 2 is going to leave y with power 2. And then add. We factor out 7 from 35, which leaves behind 5. We took out x cubed, and so that's gone out to the front. And y squared, we've also factored to the front. So all that's there is a 5. That would be the answer. So we've taken our expression, written it as a product of two polynomials. And next one. We are factoring 9x squared minus 3x to the 4th plus 12x to the 6th. Okay, I kind of need to check out the factors of all the numbers. So I'm just going to write this back down. And factor 12, which we could do like 6 times 2. 6 is 3 times 2. 3 is already factored. 9 can be factored to 3 times 3. So we need factors common to all terms, which there's a 3 and a 3 and 3 in each of the terms. So that's going to be part of the greatest common factor. And even though there's a factor of 2 here, it's not common to this middle term or to the first term. So we're not going to use 2 in the GCF. We do use x, and we pick the smallest power, x squared. Again, there was a 3 common to all terms, but only one 3 each of the terms. So just one of these. Next with factoring. Our 9x squared minus 3x to the 4th plus 12x to the 6th. Into, we're taking out 3x squared. And we remove 3 from the first term, which leaves behind a 3. And we took out the x squared. So that's done. And subtract. From this middle term, we've factored out the 3 to the front. We've taken away x squared, or factored out x squared. So what's left is an x squared. Plus factor 3 out of 12, and it leaves 4. Take away, or factor out x squared from x to the 6th. It's x to a power of 6 minus 2. So x to the 4th. So when you are asked to factor, the goal is to rewrite your expression as a product of polynomials. So this is how the answer should look. A number times a number, or a polynomial times a polynomial. Let's do another one. We're going to factor. Five AB squared. Add 10A squared B squared. Add 15A squared B. Okay, I'm going to use this part. We're going to factor 10. It's 2 times 5. And 15 would be 3 times 5. There are 3 terms, and we're trying to get factors common to all terms, which there's a 5 and a 5 and a 5. So we're going to use 5 in the GCF. Okay, there's a 2 in the middle term, but it's not common to all terms because the first term doesn't have 2. And then same for 3. There's a 3 in the last term, but not the other 2 terms. So we don't use those guys because they're not common to all 3 terms. There's your variable a, and you want the smallest power, which is here, a to the first. And then pick that variable b with the smallest power, which is over here, e to the first. Okay, so we can factor out 5ab. And just to be clear, we're going to rewrite the polynomial 5 squared. 10a squared b squared, 15a squared b. And then we're going to rewrite it again in factored form. So factor out 5ab. So we've taken 5 to the front, a's to the front. We need to take b from b squared, which would be b to the first. Factor 5 out of 10, it leaves 2. Factoring out an a from a squared, which leaves a. And b factored from b squared leaves b. Take factor 5 out of 15, which leaves 3. We factored out an a from a squared, so an a is left behind. And we've got that we brought the b to the front. So there's just a 3a. This is how your answer should look. You should have this kind of full expression now written as a product. Okay, we want to factor by grouping. So the idea is just to see if you can factor the greatest common factor out of pairs of terms. Okay, so first we're gonna pair terms up, factor them, and then what's left over, we're gonna pair those up and factor those too. Okay, factor. AX minus BX add AY minus BY. Add an AY, take away a BY. Okay, so I mean, if you want to, you can rearrange this a bit. Like you could try, there's an A term, an A in this term, there's an A in this term. You could put this over here and have AX plus AY. But you could also just leave it how it is and just pair this first two guys together. They've both got X in them. These both have Y. So I'm just gonna leave it how it is and just put these together as a pair. I'm gonna put these together as a pair. From the first pair, we factor out X. From the other pair, we're gonna factor out Y. So again, from these two, from that first term, what's left behind is an A. Factor X from BX, and it leaves B. From this pair, we're going to factor out Y. Positive Y. From the first term, which if we factor Y out of AY, the A is going to stay behind. Take Y and factor it out of BY, leaves the negative B. Okay, now we have two terms. There's X times A minus B as your first term. The second term is Y times A minus B. So this factor has an A minus B. And I'm sorry, the first term has an A minus B. Second term has an A minus B. So from this pair, factor out a minus b, which can look weird, but after you practice it a bit, it gets more comfortable. Okay, so before the plus sign, we're factoring out a minus b, which leaves the x. And then we've taken care of that, and we add factor a minus b from this term, which would leave the y. And then we're done. We've got a minus b times x plus y. That is the factored form of that expression. Polynomial. Okay, I'm gonna put this up, but then I'm gonna try grabbing a different pen. So we want to factor x squared plus ax add 2x, add 2a. I'll be right back. Okay, I'm back. Let's see. Again, if you want to rearrange this, you can. These both have x's in them. These both have a's in them. But I can just leave it how it is. The last two terms are even. So from here, we'll factor out a 2. And from the first two, we'll take out an x. So we're going to pair them together. Squared add ax, 2x add 2a. So from this first pair, we're factoring out x. X from x squared leaves an x. Factor out an x from here, and it leaves positive a. Okay, now we're on to these two terms, where we're going to factor out 2. So if we bring 2 to the front, positive 2. And from here, if we factor out 2, it leaves an x. And factor out 2 from there, it leaves an a. Okay, so now we've got two terms, this one and this one. So from this pair, they've got a common factor of x plus a. And that's what we're factoring out. So if we factor out x plus a, from here it leaves an x, and from here it leaves a 2. X plus a times x plus 2. So we've gone from this kind of fully expanded form to a product, to this binomial times this little binomial. factor. X cubed minus 5x squared. Add 4x and subtract 20. I think we can just pair them up right away. So I'm gonna just copy down the problem as it is. And we're going to put this first pair together. From that pair, we're factoring out x squared, the GCF. Just for those two terms though. So x squared factored from x cubed leaves an x. X squared factored from here leaves negative 5. From this pair, we're going to factor out positive 4. Which would leave an x and a negative 5. Okay, so there's this term plus the second term. So from this pair, there's x minus 5 in common. So we're going to factor out x minus 5 from both of those terms. Take it out of the first term and it leaves the x squared. Take it out of the second term and it leaves behind a plus 4. Positive. Okay, and that's the answer. We're trying to write this big expression as a product of polynomials as fully factored as we can. So like as smallest powers as possible. All right, let's this is one more factoring by grouping, and then we're done with notes for the homework 6. We're going to factor x squared y minus y plus 3x squared plus 3. And I mean, these both have x squareds in them. I could do it that way, but I'm just going to leave the first pair together. They both have a y. And this pair at the end, they both have a 3. So I'm just going to group these and group those and factor out the greatest common factor from each of them. Okay, putting these two together and factoring out a y from that pair. So factor out a y, it leaves x squared. Factor out a y would leave a negative 1. And then from here, we're going to factor out positive 3. which would leave an x squared plus 1. Oh, something's wrong. I have a sign off somewhere. This is supposed to be a negative sign right here. Okay, so if there's a negative sign, and I'm just going to stick with this. We're going to factor out 3 from the last 2 terms, which means what's here is a negative x squared and plus 1. But if I have common factors, then I can factor further and bring out that common factor. And they're almost the same. It's an x squared minus 1 and a negative x squared plus 1. So these are called, sometimes they're called opposites, but often they're called almost the same factor, where the difference is just a negative sign. So let's take that negative sign out. We'll factor it out from here. So we have a y times x squared minus 1. And then factoring out a negative makes this negative 3 times, or then minus 3 multiplied with positive x squared minus 1. Cool. Now I can keep factoring out x squared minus 1 from both terms. There's a term before this minus sign and a term after the minus sign. The first one has an x squared minus 1. The other one also has an x squared minus 1. So factor that out. So factor out x squared minus 1, it would leave the y. And then from here, take that out to the front, it leaves negative 3. And hopefully we have time to get to it today, but x squared minus 1 can be written as a difference of squares. So we can factor this part further, which is the goal. We want to fully factor every piece in this product, and this piece can be broken up. Okay, so we still need to go on. And just keep factoring. So we're x squared minus 1. I'm going to write it as x squared minus 1 squared. Multiplied with the y minus 3. X squared minus 1 squared is the difference of squares. It is the product x minus 1 times x plus 1. Or you could do the x plus 1 times x minus 1. As long as there's a plus and minus somewhere. And close that. So we factor this down to its, I guess it's fully factored. I'm kind of slipping on how they say, like down to its smallest something. I'm blanking on it. Okay. Let's do another. Oh, actually, we're going to factor, but different kinds of factoring aside from greatest common factor and grouping. So this would be notes for homework 7. So we're going to factor trinomials, and it looks like a polynomial with 3 terms. So it's factoring a polynomial of the form and some number a times your variable x squared, add some number b times x, and add some number c. Ax squared plus bx plus c. There's 2 ways. The way I first learned it was called diamond method, or you use a diamond to factor a polynomial like this. Use a diamond, which I'll show you. I also learned this grid method, which either way it's guess and check. I'll show you how to use the grid as well. No matter what though, there's other methods out there, sure, but pretty much no matter what you do, you have to guess and check. Okay, first one we're going to talk about is this diamond. And it's like for your polynomial that looks like ax squared plus bx plus c. So you draw a big X. In some semesters, we've just called it big X because that's all you really need to draw. But I know if you went to Google it, it's kind of popularly known as this diamond. So you draw this. That's all you really need, but the name diamond comes from putting a little outline around your X. Like that. What goes here is A times C. The 2 numbers at the ends multiply together and go in the top. A times C. And then whatever number's in the middle with the variable X, it goes down below. Then you have to fill in the sides with guessing and checking. Here you pick out 2 numbers that multiply to AC, and they have to add to B. I'm going to just redraw this. It looks a little messy. Here. Do A times C and put that in the top. B goes at the bottom. We've fill in guesses with two numbers that multiply to AC and add to B. Okay, once you get the right guess, you use those two numbers to rewrite the middle term, and then you factor by grouping. I know that there's like some shortcuts out there, but I don't want to do any shortcuts with the diamond because I've seen mistakes happen. So after you've done the two numbers that multiply to AC and add up to B, then use those numbers to rewrite the middle term. Okay, we're going to factor x squared plus 7x plus 10. So we're gonna do this scratch work where we make a diamond or a big X. You take 1 times 10, which is 10, and it goes at the top. The middle term, 7, goes down at the bottom. We need two numbers that multiply to 10 and add to 7. So you can try if you did 1 times 10 is 10, but you can list out your guesses on the side maybe. Let's do this. 1 and 10 is an option, but won't work because 1 times 10 is 10, but 1 plus 10 would be 11. So we're gonna move to 2 times 5. 2 times 5 is 10, 2 plus 5 is 7. So that's the guess. And we use the numbers 2 and 5 to rewrite 7x. So we take this and leave the x squared, rewrite the middle term as 2x plus 5x. Then we need the plus 10. Okay, so from the first pair, we can factor out an x. From the second pair, we can factor out a 5. Okay, they've got two terms. This one plus this one. They both have x plus 2 in common. So factor out x plus 2. From the first term, it would leave the x, and from the second term, it leaves the 5. I'm going to do another one using this diamond. Factor 2x squared minus 5x minus 3. I think I'm going to do my diamond somewhere over here. So you put the first number and the last number multiplied together, which would be 2 times -3. It's -6 on the top. The middle number goes on the bottom, -5. You always have to guess 2 numbers that multiply to what's at the top and add to what's in the bottom. You do 6 and -1. Let's try this. We put 6, -1, multiplies to -6, but adds to +5. So let's try this negative sign here. -6 times 1 is -6. -6 plus 1 is -5. So that's our guess. Use those numbers to rewrite the middle term. We're going to take 2x squared minus 5x minus 3. It's equal to 2x squared. Instead of minus 5x, we're going to minus 6x and then add a positive x. So that's me using the guess to rewrite the middle term, and then there's that last piece, -3. Now I can group these together, factor out a 2x, and then I think I'm just going to put parentheses around here. We'll see. I think it'll help to make it look clear. This pair and this pair. 2x factored out leaves an x. Here it's a -3. Then we've got plus x minus 3, which I'm going to put in parentheses just to make it clear. Then I can factor out x minus 3. There's an x minus 3, which we can write times 1 if we want to. So from this term, we're factoring out x minus 3. The same for here. Factor that out and it leaves 2x. Factor it out of here and it leaves a +1. X minus 3 times 2x plus 1. We're going to do one more using a diamond, and then I want to show you how to use the grid, because this grid method works every time as like a shortcut. You can, but don't have to go through scratch work. All right, we're going to factor 2x squared. Nope. We're going to factor 2x squared plus 4x minus 30. minus 30. Let's do the diamond first. So you'd have to have 2 times negative 30 up here, 60. Oh, actually, we could. Let's do this first. I can tell. I could tell we could factor out a 2. We could take out the greatest common factor, which would be 2. That's a good place to start. Two times x squared plus 2x minus 15. Nice. So what we want to factor now is what's in the parentheses. So we're going to do a diamond for this stuff in here. So we don't want to forget this 2 being multiplied out front, but right now for factoring, we're just looking at this part where the first number is 1, multiply with the last number negative 15, and put that in the top. Then put the middle term in the bottom. You need 2 numbers that multiply to negative 15 and add to 2. I'm thinking probably 3 and 5. Let's put down 3 next to 5. Then we need a negative sign somewhere. Negative 3 times positive 5 would be negative 15. Oh, cool. Negative 3 plus 5 is positive 2. So I got the right guess. Negative 3 and 5 are the numbers I'm going to use to rewrite this middle term, 2x. There's the x squared. Instead of 2x, we're putting a minus 3x and a plus 5x. And then minus 15. Inside the parentheses, we're going to group together x squared and negative 3x. And group together the 5x and negative 15. All right, let's see if I can get this. So 2 times. I'm going to change these parentheses out here to square brackets because we're going to have parentheses inside. Just helps keep it organized. All right, we're factoring out an x from x squared minus 3x, which would leave x minus 3. Here, factor out positive 5 times x minus 3. Oof, got messy. I'm going to redo this here a little bit. Okay. So there's this first term, x times x minus 3, plus a 5 times x minus 3. So inside the square brackets, we're factoring out x minus 3. start out with that 2. It's multiplied with, inside square brackets, we factor out x minus 3. Leaves an x from the first term and a plus 5 from the second term. And now that I've kind of got everything nice and organized, I can drop those extra brackets because it's kind of clear what's going on now. I want to take a 2, multiply it with an x minus 3, multiply it with an x plus 5. I think we've got time for me to at least explain a grid, and then next time we can practice. So this is something a friend showed to me. And it works really good for when you've got more than one variable in your trinomial. Let's call it. It's not a name, it's a lowercase g, G-R-I-D. I'm going to write down steps and then it will help once we do a problem. Okay, first. First is you draw your grid, and I'll kind of show you how to draw it. But you just want to like separate the 3 terms and then kind of underline it to set up a space to guess and check. Once you've got this drawn, you find 2 numbers that multiply to the first term and 2 numbers that multiply to the last term. I think the first example we'll do is this problem again, but using a grid instead of a diamond. Okay, 2 numbers that multiply to the first term and 2 numbers that multiply to the last term. Then once you make, this is another guess and check. So you're picking 2 numbers and 2 numbers, and then you give it a try. You cross multiply. And then add the ends. If the sum is the middle term, then the factors are in each row. So like when I mean by row, like we have this grid and these guesses, and you want to go straight across if you've got the right guess. I think an example will help. It's the same problem we did. It's 2x squared add 4x, subtract 30. Let's just copy down the problem. Then we draw the grid. So what you want to do is keep the signs with like their corresponding number, like this negative sign is on 30. So you want to split this up as 4x and negative 30. So I draw a line through here. And then also keep that plus sign with the 4x. We're going to draw a line through there. Then we're just going to underline this whole thing. That's my grid. Maybe a little bit longer on this sides here. Okay, so now we're here. Find two numbers that multiply to the first term, like 2x times x. And we put that 2x times x is 2x squared. Okay. And now over here, this is also the side where I usually try guessing different numbers and leave this how it is. But maybe sometimes you have to come back here and try a different guess on this side. I'm going to leave the 2x and x where they are. For two numbers that multiply to negative 30, I could use something like 2 and 15, or 30 and a negative 2 and 15, or maybe 30 and negative 1. Let's just do a random one, like 2 and 15. We'll put the negative here. Negative 2 times positive 15 is negative 30. And this is just one guess. Okay, I've done this. Cross multiply. So go 2x times negative 2 is negative 4x. Then go across this way. X times 15 is 15x. Okay, and then we add those ends. We're going to add 15x with negative 4x, which would be 11x. Okay, if the sum is the middle term, then I have the right guess. But my sum is 11x, my middle term is 4x, so this is not the right guess. So we're just going to try this whole thing again. It's totally cool to just guess and check and then guess and check until you get it right. Okay. So we're trying to factor 2x squared add 4x minus 30. And I'm going to draw a grid. I'm going to stick with 2x times x is 2x squared. Let's see. We're going to use, instead of 2 and 15, we're going to try 6 and 5. And I'm going to go with 6 here, 5 there, and one of them needs to be negative. So here, negative 6. Positive 5 times negative 6 is negative 30. Okay, so then we're going to cross multiply. X times negative 6 is negative 6x. Need more space. Two x times 5 is positive 10x. Now that we've got these ends, we're going to try adding them together. If it is the middle term, then we do have the right guess. 10x plus negative 6x is 4x. And we're pretty much done. So yeah. That is the right term, that is the middle term there. So what you do is drop parentheses straight across. We're going to take 2x minus 6 and multiply it with x plus 5. So take that row, multiply it with that row, and that's your factored form. But also from this first factor, we can factor out a 2. So we're going to take the 2 out of this first pair of parentheses, which leaves x minus 3. And you also have that x plus 5. All right, we're done for today. We're going to keep on practicing this grid next time. And we'll use all of our factoring techniques to solve equations like with factoring. Okay. Just put this here. We're done. Thank you, everybody.